Experiment 5. PCB Production. Part 3. PCB Soldering and Testing. The aim of this experiment is to teach students how to produce a PCB board out of a given PCB layout design. This set of videos shows how to produce a PCB board for the 4-bit binary counter circuit designed in the previous experiment. The third video shows the soldering and testing phase of PCB production. Basic soldering techniques. The following video explains the basic soldering techniques and equipment used to solder. This video is produced by the EPS e-learning team at the University of Manchester, UK.
This video shows basic soldering technique and the equipment used to solder. There are two main types of soldering iron. The iron to the right has a station which shows the temperature on the display. The controls adjust the desired target temperature. The one on the left works at a fixed temperature but is used in the same way. If you're using a digital iron, then set the target temperature to around 350 degrees C and wait for the iron to heat up. When you're not soldering, remember to keep the iron in the holder. Be careful when you're soldering not to put the iron in contact with the lead. Some soldering irons have PVC-coated leads which will melt through easily and pose a risk of electric shock if touched. The best leads to use are made from silicon, which won't melt at the temperatures soldering irons reach. The other item you'll need is, of course, solder. Solder is a low melting point alloy which flows easily when heated to its liquid state. When it cools and solidifies, it fuses to the surface of a metal at the molecular level, providing good electrical conductivity between two metal surfaces. Solder normally contains flux, which helps the solder to flow and also helps make a good contact by removing the oxides on the surface of the metals being joined. Although modern flux is not toxic, when soldering you should always use a fume extractor to prevent the fumes from the flux irritating your lungs. The fumes are extracted by a high-efficiency particulate air filter, or HEPA filter, before the air is returned to the room. Before you handle the components, it's strongly advised that you wear an earthing band to prevent electrostatic damage to the components. There are two different soldering types, surface mount and through-hole. Surface mount connections are made by heating components with pre-applied solder in an oven so that it melts and joins to the surface of the board. For this tutorial, we'll look at plated through-hole soldering, which is done on boards with printed circuits on both sides. Through-hole soldering is when components are pushed through a hole in the board and soldered from the other side. The solder flows through the hole to make the best possible contact. First, take your component and create a bend in the legs with a pair of pliers, so that each leg is at a right angle. Push the legs through the holes in the board at the appropriate place and push it all the way down. Then turn the board over and bend the legs slightly to lock the component in place. When the iron is up to temperature, first clean the tip of the iron on the wet sponge on the iron holder to remove any excess solder and flux residue that might be there. You then apply heat directly to the pad for about a second, before placing the solder in contact with the pad. When the solder starts to melt, feed it in for about a second. Take the solder away, but leave the iron on the pad for another second. Then take the iron away and let the connection cool. Let's have another look at that. Before you make another connection, it's important to remove any excess solder remaining on the tip of the iron. This is because any flux in the solder will vaporize until there's none remaining. If you try to make a connection with solder without any flux in it, you risk making a bad connection. When you turn the board over, you should see that the solder has flowed through the hole by capillary action, guaranteeing a good contact. Trim the leads just above the solder using some wire cutters. When you cut the wires, be careful that the cut end is held captive so that it doesn't fly off. This can be done by putting your finger on the end when cutting. If you make a bad joint or want to remove a component, you can remove the solder by using a desoldering pump. This is a spring-loaded piston with a trigger which when released creates a vacuum which sucks the solder up. Cock the pump. Use the iron to melt the connection and put the tip of the pump onto the melted solder, then release the trigger. You might have to repeat the operation several times to clear all of the solder. An ideal solder should look like a cone with slightly concave sides, showing that the solder has flowed through the hole. You can see all the solders here look regular. Bad joints are noticeably different to the concave cones of good joints. If your joint looks like any of these, then it'd be wise to remake it. Bad joints can lead to intermittent connections or no connection at all.
Soldering the counter board. This part shows how to solder the 4-bit binary counter board printed in the previous part of the experiment. The following components are used in this experiment. 1. PCB board. 2. The 74LS393IC chip. 3. Light-emitting diodes. 4. T-block connectors. 5. Soldering station. 6. Solder wire. 7. Bench vise. Start by mounting your devices, counter chip, light-emitting diodes, and connectors on the top side of the PCB board, as shown. Use tape to fix the devices on the top side of the PCB board to keep them from falling down when you start soldering the bottom side. You can use a bench vise to hold the PCB board in place while soldering. Start soldering your board, as explained in the tutorial video shown earlier. Remember to clean the tip after soldering each pin. When you are done, trim the pins of the light-emitting diodes just above the solder areas. Testing the counter board. This part shows how to test the 4-bit binary counter board printed in the previous part of the experiment. You need to connect your board to the digital trainer as follows. 1. Connect the VCC pin in the first block connector to the plus 5 volt in the digital trainer. 2. Connect the ground pin in the first block connector to the 0 volt pin in the digital trainer. 3. Connect the CLK pin in the second block connector to the 10 Hz frequency output of the digital trainer. 4. Connect the MR pin in the second block connector to a logic switch in the digital trainer.